Carbon-14 is an isotope present in all living things, but it decays when they die to regular old carbon-12. After every 5,730 years, the amount of carbon-14 present decreases by half. Okay, so we lose 50% of the carbon-14 we have after that amount of time. By solving a differential equation, find a function in terms of the number of years t representing the percentage of carbon-14 present after death. Okay, so our function is going to express percentage. We need to solve a differential equation. Well, the first thing we should do is set up a differential equation. Okay? Now, it's an isotope, so we're probably looking at sort of a radioactive decay situation. Okay. So what can we do? Well, if we're going to decay, we might, well, let's first declare a function, because that's what we're after. So we'll have m of t be the, let's say, mass of carbon-14 present. Actually, technically it should be percentage, right? So we'll call it P of T. Okay, percent of carbon-14 present. All right, and what do we know? Well, this changes. Okay. It changes over time. It's decay of a compound, a chemical compound, an isotope. So we're going to use radioactive decay, which says that the rate of decay is proportional to the amount of material present. Okay. So there's a differential equation here. The change in percentage is proportional to the current percentage. Or if we were doing it with mass, change in mass of the isotope is proportional to the current mass of the isotope. Okay. So let's go ahead and solve this. We could treat it as a separable differential equation. So we rewrite, group everything over in terms of t on the right-hand side. K is just a constant, so it's a function of t, technically. Now we bring the p, or p of t, over to the other side. And we go ahead and we integrate. Raise both sides to the e, or raise e to both sides. I always end up saying that wrong. Okay. So we'll get p is equal to e to the kt plus a constant. But that's really e to the kt, e to a constant. But since we don't know what c is, e to the c is just some other constant. So we might choose to express it like that. And technically you don't have to. If you want to leave the c up there, go right ahead. Okay. So there's our sort of template for what our function should be. The percentage over time, or as a function of time. T here is in years. And what do we know? Well, we know that as soon as you die, carbon-14 starts decaying, but right at the moment of death, so after 0 years of death, because T is supposed to be in years, we have 100% of our carbon-14. It's only right after that moment that things can start to decay. So that's a useful piece of information. So 100 should be d e to the k times 0, 0 years. And that tells me d is equal to 100. So this helps us better refine our function. But we still don't know this constant of proportionality. We still don't know this k value. Okay. But we're told something else. After, I think it was 5,730 years? Yeah, after 5,730 years, we should have lost half of it. So we should have 50% left. Okay. So then 100 e to the k 5,730. Okay, or we could choose to write the k afterwards. Okay. That gives us a new equation. Divide both sides by 100, you'll get a half is e to the 5,730k. Ln both sides. Okay. We could write this as minus ln 2 if we wanted to. And we might choose to. Some people like having no fractions in their logarithms. But ultimately, we go ahead and divide by 5,730, and we've got k. And all we wanted was a function, right? Yeah, we just want a function. Well, we've got our k, we've got our d, and that means we have our function representing the percentage, not the mass, but the percentage of carbon-14 left in the body. So 100 e to the minus ln 2 over 5,730 t. Okay? Now you could go ahead and simplify the e to the minus ln 2, so there are other ways to write this. And I would encourage you to try and rearrange it on your own to get 100 times 1/2 to the power of t over 5,730. So that's another equally valid expression. It really depends on, are you concentrating on the half-life aspect of things, or are you going to be doing more calculus, and so you want the e around? Okay. But both are perfectly good expressions for the percentage of carbon-14 present after death.